Good morning, everybody. Welcome to this talk session. Now that my phone is working again, I am very pleased to present Kim van Wyk, whose talks are always fascinating, talking about dynamically serving REST endpoints for database procedures with FastAPI. I know what most of those words mean, and I'm looking forward to seeing what the order tells us about them. Kim, over to you.
Thanks, Jeremy. I'm also looking forward to figuring out what the order says about them. By the end of it, one of us should hopefully know. Then you can tell me. Right, thank you. Good morning, everyone. Dynamically serving REST endpoints for database stored procedures with FastAPI is possibly the longest title I have ever attached to a talk. It does mean something. I'm hoping it'll make a bit of sense by the time I'm done. Oh, that's useful. And my PDF program is... there we go. Thank you. It clipped off the what is this about part, then how are you supposed to know what the slide's about? This slide is what it's about. The problem I was looking to solve, and I suspect it's not unique to myself, I would imagine anybody who works for a sizable organization who uses a database for something has got more or less a similar problem or similar situation. This part was not the problem. My employer has a large number of Microsoft SQL Server stored procedures, which apparently I can't say. This is the heart of several important backend systems, and again, I suspect this is true of many systems. Our stored procedures run regularly. They do things important. We're a financial institution. They do financial things. They do processing things. They do all sorts of things that are critical to our business. They've been built up over many years. They've been battle-hardened. They do the fine little weird corner case problems. That way. Okay. Better? Worse? Yeah? Jump up and down. I don't know. They fix the little battle-hardened problems that, arise. There's weird corner cases. Somebody's name has a character we didn't anticipate. The stored procedure's been updated to fix that. Turns out that somebody has a negative balance somehow in their financial transaction because something weird happened 20 years ago. Stored procedure's been adapted to fix that. You could recreate those systems, but you'd be forever fixing the problems that you've already battle-hardened and tested and got working in your previous systems. And now I can't see what I'm talking about. So I have to go back here. Fix the can't see problem with that. Okay, I'll read from there. They're reliable. They're well understood. Every time we want to make a change to our system, you go and make a change to the stored procedure. It's audited. There are DBAs who know what they're doing. There's people who can read those scripts. There's people who can say, yes, we want to do this. Yes, at an audit level, we have approved that this change has been made, or why the heck are we doing this? It's well understood. Everybody knows how it works. And every time we want to make a system change, you can change your stored procedure and everything is understood and written down and we know how it goes. And this might be unusual. I hope it isn't, for your sake, because I'm lucky. Ours are consistently defined. All our stored procedures take in a bunch of parameters with set kind of known names. They're heavily documented. There's more documentation per stored proc than there is actual stored proc. And there's an output message and it always comes out in a thing called MSG. This part I only say to make you jealous in case this isn't true of your stored procedures, but it made my life much easier. If I can pick on an audience member, my direct manager used to be our chief DBA. He wrote them mostly, or had a lot to do with it, so that's all. I'll take the slight payment later around school. Thanks. The problem with this, though, is that these are great internally in the system. Somebody writes a stored procedure, somebody opens up SQL Server Management Studio, somebody runs a stored proc, we note that we did it, cool. How do we make our other systems talk to that is a bit of an issue. It would be useful if third-party systems could use these stored procedures. If some third party is providing a service to us that would use something one of these things does, say client management, we have a stored proc that's going to update your surname all across our system. It would be useful if the third-party system could use that. We have a perfectly good wheel. As I point out, battle-hardened, excellent wheel that runs nicely and does these things. We don't want to reinvent that. You could give direct access to the database. Your security people, not unreasonably, don't like that idea. For excellently good reason, you should not be giving direct access to your database to your third parties. And I'm pleased to say we didn't consider that. And many systems, although some will, lots of systems don't understand SQL. They don't know what a stored proc is. It's a specialist-ish thing. You have to know what a database is. You have to know what a stored proc is. You have to know how these things work. REST endpoints would be very nice. More systems understand REST, or at least APIs. Let me not kind of shut Stefan out of the conversation. That we could do SOAP, we could do XML as well, but REST is what we preferred. Endpoints would do the job very nicely. Everything understands them. You get Swagger documentation or similar for documenting it. You know how it works. Everything's good. And REST would be nice. Okay. I wanted to basically make some REST endpoints that speak to our stored procedures. So you can fire up a REST endpoint. The stored procedure takes in input parameters 1, 2, 3, 4, and 5, and it puts out parameter MSG. So I want a stored proc that takes in parameters 1, 2, 3, 4, and 5, returns message, has all the things you normally get with REST. So if input 1 is an int, it wants an int. If input 2 is a date, it takes a date, etc. At this point, I should point out, yes, I could have just done this by hand, and this talk would be very boring. You'd be spending 40 minutes watching me very, very tediously write out Pydantic models, followed by FastAPI code, as I very carefully read the stored procs and wrote one by one what all the stored procs did. We've got dozens of these things. Again, I suspect we're not alone. Many people have dozens of these things. Many people probably have hundreds of these things. That's weeks of work. If you did this by hand, somebody changes the stored proc, then somebody else has to know how to go and change the code. It's a new audit chain. It's a new dependency. It's a bit iffy. Doable, but not fun, frankly. I wanted to dynamically generate them, and it occurred to me that surely you can do this. Surely you can ask your database, give me all your stored procedures, tell me everything we know about them, let's make some REST endpoints. I thought this would be pretty simple. I was fairly confident I could ask SQL Server to tell me about the stored procedures in a query, and voila, done. That I'm right, that is easy. Then I thought I could ask FastAPI to take the results of a database query, make me some dynamic Pydantic models, feed those into FastAPI, and simply say in like 10 lines of FastAPI, here's some models, make me some endpoints. No. I could not figure out how to do that. I've crossed out the dynamic FastAPI endpoints. That's the part I could not make work in this approach. I added in generated FastAPI code, because what I can do is write some text that I then run later, which is the heart of my talk. And this, one of the things I'm trying to point out is, if the easy approach doesn't work, you could fall back on code generation. It is an option. And then we'll touch on a bit of Dockerization just because I like Docker. As you'd expect for actually getting your stored proc, this part's not hard. I'm going to move slightly back here if we're not getting too much interference. You can write a query to get your stored procedures out of SQL Server. Simple. I'm not going to go through all the code, but that's it. That's literally the query you write, and it gives you something that looks not dissimilar to that. Here I have 2 stored procedures. I'm very imaginative and inventive in my company naming, so I have proc1 and I have proc2. They have params 1, 2, and 3, and they param 3 is an output, params 1 and 2 are not. I must assure you our naming is a little better than this. This is just demo basis. So that's easy. That part you can do. Stored procedures, call your database, get your queries back, simple. Then I thought, okay, well, fine. I can dynamically generate some FastAPI endpoints. FastAPI is just reading models, basically from Pydantic. Pydantic can probably be told, here's a database, make some models magically from this database. I probably have to provide some input as to how do you turn the int from the database into an int, bad example, instant int. How do you turn the varchar from the database into what kind of string you want, that kind of thing. I expect it to have to do that. Pydantic can do that perfectly fine. Got a create model method, you can give it your database, and out comes input and output models dynamically created, etc. I could not find a way to have FastAPI use those dynamically created models. Everything FastAPI wants must already exist. You need to be able to give it a file. I have to call it models.py, but I'm a kind of consistent, somewhat boring individual, so it's always called models.py in my code, and it wants one of those to exist. There are some clever tricks you can do. There's some solutions discussed in some GitHub issues that looked like they would do the right thing. That was a lot more Pythonic navel-gazing, as I can put it, that I was comfortable putting in my code, mainly because A, I didn't understand it. I didn't think I was likely to understand it, and I didn't want to open the code 6 months from now to change something and then think to myself, what the heck were you doing 6 months ago? I mean, I do that already. I didn't want to do it anymore. Open it 6 months and see, what the heck are you doing? And why? What is this? So I didn't do that. Plan B, code generation. Ginger 2. I actually don't know what happened to Ginger. It's now Ginger 2. I assume there was at some point a Ginger, but Ginger 2 is what we're talking here. Ginger 2 is a code generation templating tool, effectively, which if you've ever come across it, you'll have come across it almost certainly in the context of Django. It is the thing you write in your Django template when you want to insert a variable here. It's got 2 braces. on either side to insert a variable. It's got a brace and a percent to insert some logic. That is Ginger doing that in the background. Ginger, that said, is not a Django-only thing. It's not baked into Django. Django's just using it. You can use it yourself. You can run it standalone. You can generate any text you like. So I came up with some templates to generate a Pydantic models.py, because as I said, I'm a boring, somewhat consistent individual, so models.py it shall be, and a FastAPI main.py file, simply because FastAPI likes to find a main file, and who am I to argue with FastAPI? These templates are not particularly complicated. Code in presentations is never massively huge fun, so I'm not going to go through it all in detail, but this is literally the template I wrote to get me a models.py file. Here is some Ginger, here's some more Ginger, little bits of Ginger. It's as always in a demo, it's a lot simpler than my actual code, but not by much. I mean, I took 10 lines out, maybe. It's not super complicated, and this is just a for loop. I'm going to whack in everything I know about my databases, and I'm going to end up with a massive long file of models. That's what you end up with. In my simplest case, I passed in proc1. I'm about to point the laser at the screen like that's going to be helpful. I passed in proc1. I told it I had param1 and param2. No, actually, I didn't tell it that at all. My generator told it I had param1 and param2. That's an int and a string. The DB fields thing is something that is just worth noting, but isn't necessarily always useful. But at some point, I'm going to have to call a stored procedure, and I'm going to have to be able to go from a FastAPI input string to tell it what to actually give the stored procedure. So is that a varchar? Is that a float, or etc. So all this is a little pedantic trick to basically have an internal mapping of what you actually call the database fields when you end up calling the stored procedure. It's just a dictionary that travels with every model. Pydantic isn't using it. Flask isn't using it at all because Flask isn't involved. FastAPI isn't using it, but ultimately my stored procedure caller would need it. So that's what I end up with. Proc1 input model, proc2 output model. I don't know why I don't have proc1 output model, but fine. Param3, etc. That's a typo. Okay, never mind. Pretend you didn't see that. That's easy enough. I could have written this by hand, but when I've got another 40 stored procedures or 50 stored procedures, etc., as I say, it gets a bit old. Similarly, and again, I'm not going to waste too much time, here's my main.py FastAPI model. If you don't know a heck of a lot about FastAPI, it doesn't necessarily mean stuff to you. But again, it's one template, it's one page worth of code, and that's enough to get you a FastAPI model. A FastAPI method. And then at the heart of this thing is just basically calling my stored procedures on my database. And that's what I end up with. A FastAPI model. Say that again. FastAPI method. Proc1 takes in the Proc1 input model. It expects to give you Proc2's input model. It calls a stored procedure. Something goes wrong, it tells you about it. Otherwise, you get the model back. Repeat that for 40, 50, 60 stored procedures, and there's a lot of stuff I did not have to write by hand. At this point, I shall very bravely attempt to do a demo. Right, how's that? Big. Cool. So to show there's nothing up my sleeve, this is all that's here. There's a db.py, which is literally the thing that talks to the database. There's db.SQLite3, which is SQLite3 database. Generate code, which actually does the work. And a generated directory, which I shall demonstrate, is empty. Okay, no, nothing up my sleeves, empty directory, all good. That's the entire thing that's in my SQLite directory, the SQLite table. It took me forever to come up with this, as you can see. I'm faking this now. This is not actually a stored procedure. This is a table that returns things that look like a stored procedure, and I'm going to fake it more when I get to the demo because I'm not going to call the stored procedure either because it doesn't exist. But same idea, you run the query, you get something back that looks more or less like this. Now, because I wrote this more than an hour ago, I don't remember what the next step was. So thank you past me for writing this down. This is the model, and again, I'm not going to expect us to go through and look at details, but literally this is what my models.py template looks like. It's simplified from the one on my slide, but it's much the same thing. There's some Ginger code in here. It's literally going to end up with a file that imports Pydantic, imports datetime, and then there's a whole bunch of repeated loopy stuff in it. Similarly, if I look at my main.py, no, because it's not in that directory. And again, this fills one whole screen, but a bit of import, app equals FastAPI, and some generated methods. Now I've rolled it off the screen and I can't remember what it said, so back to steps. Okay, here's what I'm going to do. I'm going to run my generate code.py file, and I'm going to put it into the generated directory. The code is in Git if you really wanted to see my amazing, exceptional, brilliantly impossible to understand code. It's probably 30 lines, if that. It's not super complicated stuff. I'm not going to go through it line by line. It's not particularly interesting to watch me dissect my code line by line. But what generate code is going to do is exactly what we've just spoken about. It's going to call the database, get the database results, feed them into the templates, generate some text, store models.py as a models.py file, store main.py as a main.py file. That's all it's doing. Now, if we go into our directory, there's stuff that wasn't there before. Here's my models.py file. Again, this is the whole thing. But please use your imaginations. It could be bigger. You know, in a real-world situation, if I had 2 stored procedures to make REST endpoints out of it, I probably wouldn't have been dynamic. I think I might have just done this by hand. But if there's 40, there's 50, etc., you know. But that's all it is. Proc1 input model, parameters, proc1 output model, etc. Repeat. If I look at the FastAPI code, that doesn't quite fit in the screen, but there were some imports up there. Otherwise, that's all it is. Then, to finally prove that this actually works, see if I'm in the wrong directory again. Nothing more exciting than watching somebody live type and correct their typos. Okay. Here is one I prepared earlier. I have refreshed it. Here is one I prepared now. This is standard Swagger documentation. This is one of the benefits of doing this kind of thing with a REST endpoint. I didn't write this. You know, Swagger did all this. Or no, FastAPI did all this for me. I could have added documentation in here if I wanted to. Of course, I did that for the stuff I did for production at my employer. But there's no documentation in this particular one. But here's proc1. As you can see, standard Swagger documentation. It takes in param1, it takes in param2, and if all is well, you get a string back. So to test that out, hit my big try it out button here. How's the size? Yeah, plenty good. And execute it. And it is lightning quick because it didn't actually talk to a database. And we got back, voila, param3, exciting string. Now, that's not particularly useful. Fair enough, this is a demo. But the same thing works for calling all your stored procedures. And the beauty of this kind of approach, and what I really liked about it, is I don't actually have to care about what that stored procedure does. In my case, our stored procedures have excellent names. We know what they do. They're well named. They've got great kind of details about, and there's plenty of documentation I could pull out. But all I have to care about at this point is I take a piece of code, a stored procedure called X. I called X with the parameters I was given. I got an answer back, and I gave it back to you. What that did, my code doesn't care. Which also means a nice separation, and a point I actually meant to bring up a little bit earlier. One of the nice separations with this stuff as well is that I don't actually know what those stored procedures do, for the most part. I've got a rough idea, but it's not my area of the business. I don't know the exact details of exactly what I need to call to change a client's surname or update his you know, any of the details or anything like that. There are people who do know those things. They don't have to worry about doing this, and I don't have to worry about their part of the work. All they have to do is make sure the stored procedures work. They don't have to contact somebody to say, oh, by the way, we changed the stored procedure. You need to change the REST endpoints because suddenly it doesn't break. Or worse, not do that. And then the next time we call this the endpoint, it doesn't work. There's a nice separation here. Somebody who knows what they're doing is worried about the stored procedures. Somebody else who knows what they're doing asked me to do this. And then all we really have to do is generate the code as we need it. I did mention Dockerization, and I'm going to just see why that was useful. Dockerization is the first thing I think of because Docker is pretty much what we do on a day-to-day basis. If Dockerization isn't something you do, it's probably not worth introducing just for this, but it does lend itself nicely to it because you get a multi-step process in this thing. I have to call the database to get the models, and then from the models, I have to generate, well, no, sorry, two things. Well, a first step with bits in it and a second step. The first step with bits in it, get my database stuff and generate the code. Second step, run that generated code. The second step doesn't need to know the generated code didn't exist until 2 seconds ago. It's just running some code. So Docker lends itself quite nicely to that in a Dockerization manner that basically has 2 run layers. One that makes your code and one that runs it. And useful thing here is if somebody changes the stored procs, we still need to be told, we in the royal we as in the people who maintain this backend system, but all we need to be told to do is restart the Docker container. It'll go off, it'll call the stored procs, it'll make the fresh code, it'll run it and stand it up. What changed actually is irrelevant. I see I'm running quite well ahead of time, I assume, Jeremy, so that's, I'll start waffling more. A couple of things that did come out of this, and this is kind of where I wanted to spend a bit of time talking about. I could spend plenty of time showing you more impressive code, but I mean, you guys can write code just as well. I can probably much better. There's nothing superly complicated here is what I wanted to get to. When I'm talking about dynamically serving REST endpoints for database stored procedures with FastAPI is a mouthful, but what it really boils down to is have the system make you some code and run that code is really all it boils down to. Write some text files, treat those text files as code, run them. Things I could have done better, and things that are worth knowing. Those stored procs do have documentation, much of it. I could have read that out. I could have included in my endpoints. Again, the generator doesn't care. The generator's just told, take these strings, put them here. FastAPI doesn't care where it came from. It just said, here's some strings that document the thing. Show them to the user. If we ever change the stored procs, sorry, not change the stored procs. If we ever get rid of the stored procs and change to some other thing, life of me, I don't have the imagination to tell you what the other thing would be right now, but say we change to some completely cloud-based, new, whiz-bang, brilliant underlying system. The guys who are interacting with our system through a set of REST endpoints don't need to know that. Obviously, this won't magically just work. You have to generate something else, or stop generating, or something like that, but this won't magically just work. But I have, without spending weeks writing a front end to my stored procs, given myself an isolation layer between my stored procs and the world, or at least the bit of the world that we let talk to our stored procs. I could change that, and our third parties would be none the wiser. I mentioned this point a little bit earlier, and I just wanted to mainly have a shout out to the guys I work with, because your consistent and well-structured stored procedures aren't as common as they should be. I hear a knowing laugh from Stefano of agreement there. I speak this from experience. This is from my current employer. From my previous employer, there were stored procedures. I don't think anyone knew what they did, to be brutally honest. It was written down in a document that you called stored procedure X and it did something. And if you didn't do it, something went wrong. That kind of thing is not as common as it should be. So here's a little note to thank your database teams if these things are better than generally you might find them. And the other point I wanted to dwell on is this sounds complicated, or at least it did to me, a man of somewhat little brain. Generating code sounds like it should be hard. And, code generation, effectively I told the computer to write the code for me. Not really what I did. It was not an AI thing, etc. But it kind of sounds like it, and it sounds like it should be difficult. And to be brutally honest, it isn't. This took me a day or two of effort to do the actual real world system. It needs more time to, again, battle harden it and error handle and include the documentation and stuff like that. But the actual idea, here are some endpoints that really exist, some stored procs we actually have, stuff we care about right now. Make me some code and stand up an endpoint on a server somewhere inside the company that the guys who use and know those stored procs can look at the Swagger documentation and see if they're right and understand them and call one or two against the test system and make sure they do the right thing. That's not nearly as complicated as it sounds like it should be. The code isn't super huge. There's not that much of it. And the other point that I want to make, a syntax highlighting text editor is very handy for this kind of thing. VS Code might do it, but there are other better alternatives, which James will tell us about shortly. No, I'm not going to get into the holy war. I'll let James fight the holy VS Code. The last slide I just want to point out, I did write this somewhere, as talk is just a fleshed out version of that. There are slides and source in a GitLab repo, which I realize now in this slide I should actually have spelled out, but the slides will be available as well. If you really, really wanted this very moment, you could write this down and go and visit it. Otherwise, the slides will be available soon enough. Sheena, you do really want this right this very moment. Okay. And having run, I'm assuming a little bit early, it's only 9:30. That's 30 minutes now, is it, Jeremy? Okay. What I will do then is take the time to go and show you the thing that I wasn't going to do. Kill that. Okay, I've opened a kind of Emacs Lite, just to be faster. But actually, this is useless. This doesn't syntax highlight. I would open this in VS Code just to give James trouble, but I don't actually have it, to be brutally honest. So let's make this a bit bigger if we can. Shamefully, I don't have to hand the command to make my Emacs bigger. But this isn't my terminal. This is standalone Emacs. Yeah. This is why I wasn't using Emacs for this, because I can never remember how to make it bigger. Okay. One hopes that's big enough. Okay. I wasn't going to go through it line by line anyhow, but this is basically just an indication of all my code is doing. Here's a little bit of stuff for imports. Here's something Ginger needs to know, as in where are your template files, is all it needs to know. Here is a method that reads a model file. Where'd my laser go? There it is. Basically reads in a model file and basically loops over the two model files we give it, including it takes in the database data, and this does the actual generation. Again, not going through it line by line by line, but it's not hardly super complicated. Ultimately, it writes the models.py and main.py with the variables it's derived, and you end up with those two files. And the variables itself are a different file. That's what db.py was doing for us. The whole thing here, and if I open just for completeness, db.py, so that's what, 50 lines. db.py is another 40 lines, 30 lines. It's less than 100 lines of code in here to do this generation. I'm not counting the templates. Okay, include the templates, make it 150, but not thousands. All I'm doing in my db.py thing, again, calling my stored procedure, talking to my screen like you can see that. Talking to my stored procedure, doing a select, getting the results out, and then this bit of code isn't actually used anywhere, but this is the thing that would do the translation from REST speak to database speak and back. So when the database says it's a bit, FastAPI calls that a bool. When the database says it's a unique identifier, that's just a string to FastAPI's perspective, etc. So when I get it from the database, I turn it into FastAPI speak, and when I call the stored procedure, I turn it back. It's not super rocket science. And I think, although I have run a little bit early, that's pretty much everything I had to say. And I assumed that would take longer, so I'm done. I think I'm just on 30 minutes or close on, so I was expecting to take 35 to 40, so I'm actually shorter than usual. But at that point, the hand back to Jim.
Thank you, Kim. I do now know what those words mean in that order, and it's a lot less complicated than it sounded half an hour ago.
That was the point. Yes. It was supposed to sound complicated. It was supposed to sound magic and so forth. Please don't tell everybody else it wasn't nearly that complicated. They're supposed to think I'm a genius.
Cool. Any questions?
Thanks. I really like the idea of using a templating engine to generate code. It seems so simple now that I've seen it and heard it, but it's just something I didn't click in my brain before.
It didn't occur to me until FastAPI didn't do what I wanted, and I racked my brain. I thought, hang on, I just think FastAPI, I just have to give it code, right?
Yeah.
Why can't I make the code?
Yeah, so thanks for that. Question slightly unrelated to that. Stored procedures have kind of fallen out of fashion, especially in web development, where people kind of prefer to have that kind of code in their API code, and then you don't access the database through anything but the API. With you have a lot more experience with stored procedures than I do. You
That's an assumption.
Yeah, well, assuming. Do you think we're losing something by doing that? Do you think there's some advantages to doing the stored procedures, especially in a way you described that's structured and
I think
done well?
It depends pretty much entirely on your environment. In our case, like any organization that's been around long enough, we've had the databases for long enough. That's where the data is. That's where the business runs. And as I think I pointed out earlier, those stored procedures are the thing that has been hardened and tested and made right and so forth. If you were starting afresh, it depends entirely what your database does. I guess ultimately all you really have to do is get the data out of your database in one way and one way only, and stored procedures was how that was done. That said, I see no problem with using the stored procedures we've got. They're great. They work very well, and they're where the effort's gone. So I suppose it depends on where's your talent. We've got excellent stored procedure people. Let's use them. If you don't have excellent stored procedure people, don't shoot yourself in the foot and start with stored procedures because you think you should. Would be my very non-committal yes and no type, not that helpful answer. Yeah, cool.
Well, thank you for the presentation. I'm just curious about using FastAPI. Did you think about using Flask as well, or was it sort of?
I did. The reason I wanted FastAPI is just because this is entirely a REST API thing. There's not really ever going to be a website in front of it. It's entirely endpoints. So I wanted the Swagger and I wanted the documentation. I wanted everything you get out of FastAPI. There is never going to be a need to look at anything but Swagger if a human is interacting with this who isn't actually calling the endpoints. That's why FastAPI, and no better reason than that. Yeah. And also, because when I make endpoints, FastAPI is what I know. I know Flask can do it, but I've never had Flask do it, and I have had FastAPI do it. So it was a what I know thing more than anything else. But again, you could generate Flask code easily enough. Your template doesn't care what you're generating. So
Thank you. Nice talk. It occurred to me that it would be a nice project to not just interrogate the stored procedures, but interrogate the rest of the database and simply scaffold all the CRUD. Same technique.
Mm.
And then I thought, well, let's get carried away. Maybe we can scaffold, because if I understand correctly, and you can correct me, the templating is effectively data-driven generation of code that is executable.
yes.
Okay, so then it doesn't have to be database to API. It can also be API to database.
Oh, well, I
So
mean,
for example, I could generate, based on the nature of the data that I'm querying, I could generate indexes or even generate stored procedures which I execute back into the database.
You could do. I mean, to speak to your point, this bit of code here, the bit that actually does the templating, it gets in a list called rows. It has no concept of that coming from a database. It's a dictionary with some data in it at this point. It could be a dictionary with any data in it. So yes, you could, to use your own phrase, get very carried away if you wanted to start generating things, and very much so. And it's a very powerful technique that I had never used before, which is kind of why I mentioned it. Yeah. But as you say, you could easily get yourself very carried away. Yeah. Well, which I don't mean to make it sound like a bad thing. Yeah.
Questions?
Hi.
Yep,
You can hear.
good.
Yeah. First of all, it's a great talk. I really loved it because we do something a bit different. We use stored procedure to generate a SQL query that's dynamic,
Okay.
right? Because we're doing ingestion from our on-premise database to cloud, AWS. So whenever we create a new table, the stored procedure, we just give it the table name and schema. It's able to go fetch all the columns we need generated for us, and then we have one type of ingestion. We don't need to create like 10. But I wanted to ask, so in the stored procedures, are you able to create like polymorphic? I think in functions you can. I'm talking about from Postgres perspective.
Okay, at this point I should point out that stored procedures isn't really, databases isn't really where I'm much of an expert, I must confess. I'm technically a data engineer with electronic engineer background. I know enough about databases to be dangerous, and I know enough to call the stored procs. But this brilliant piece of beauty that I showed you when I said SQL Server could give you the stored procs, I couldn't have written that. Yeah. My colleagues had to give me that. So unfortunately, I'm not in a position to give you anything like a useful answer, I'm afraid. Yeah.
Yeah, that's all good. So I was just gonna actually ask if there's like two of those procedures with polymorphic, how would it deal with it?
Well, ultimately, in terms of dealing with the stored procs, etc., that was entirely me. That was a piece of SQLAlchemy code I wrote in Python. Yeah. You could get clever about that and call both and merge them in Python if you wanted to. Or the full power of Python's ability to get data out of a database and do something with it was all there. My case was pretty simple. I literally called this query and took the results. But if I called 6 queries and combined them in some way or did something clever, Python would let you do that for sure. Yeah.
Okay, cool. Thanks.
Any more questions?
Jeremy, did you keep an eye on the online stuff? Was there any questions there?
They're online.
There is an online. Yes, there's a channel. I don't know that there are, but I don't know that there aren't.
I had Discord open all of yesterday, and then forgot to turn it on this morning.
Nothing there. Okay, cool. Thanks.
Cool. So I have one question. Templating engines often don't deal well with things like indentation.
Right.
Have you run into problems with specifically generating Python code where getting your indentation wrong or getting the indentation correct is difficult with Ginger?
Not in the relatively simple case that these are, because ultimately you're just ending up with modules with 4 levels of indentation deep. It's not ridiculously complicated. This actually looks worse than the real code because I made this fit on a slide. So there's actually more indentation here than there should be. I wouldn't have broken at there, for example. Well, actually that's a bad example. Somewhere here, yeah, I wouldn't have broken there. That's probably not valid Python in all honesty, because input model is no, maybe it's a bad example. There are places when I rearrange the Ginger to make it fit. But yes, I agree. You could have to be very careful. The reason I mentioned the syntax highlighter is obviously your syntax highlighter is going to scream at you that this is not Python. It's also not HTML. It's also not anything of the sort. But a Ginger understanding editor can help to a certain degree, but you still do have to know that the valid Python looks right. I did probably end up with 2 or 3 tries where it was wrong. But at least in my case, the generated code was fairly simple to look at, and it was 3 levels deep at most. If you had 6-level deep code or 8-level deep code or something superly complicated, yes, I think you probably would run into more trouble. So, like everything, it varies, but this one wasn't too bad. Yeah.
Cool.
That triggered for me perhaps adding a linting step in your
Yes, that would have been useful.
in your generation, so that you can check that what you're generating is actually good.
I did in one way have the poor man's linter. I ran it in FastAPI and it said, okay, cool, I can run this. But that's probably not good enough for most use cases here. Cool. Jeremy, does it?
Hi, yeah, great talk. Just building on that, probably within your Docker steps, you could do some sort of formatting and validation.
Yes, that would, it would be another run step.
Yeah.
Yeah.
So then you can do some sort of formatting and validation. Cool. Yeah. So just to make it battle hardened, kind of.
Yes, that's a very good idea. When I forget that, I shall listen to this recording later and remind myself to do that. Yeah, cool.
Anything more? I have actually checked Discord now, and there is one comment there from a person in the room, which was not a question. So, nothing else. Thank you very much, Kim.
Thank you, everyone.